Question number 27. The average monthly cell phone bill was reported to be $50.07 by the United States wireless industry. A random sample of a large cell phone company found that the following monthly bill charges are in dollars. Here is our data set. And if we notice, we have 10 values in our data set. So our sample size is going to be 10. At the 0.05 level of significance, can it be concluded that the average phone bill has increased? In this case, it has given us the sample mean and the sample standard deviation, which is great. However, you guys should also know how to calculate the mean and the standard deviation by hand as well. So the formulas will be at the last page of this solutions PDF, whatever you want to call it. And I'm showing you how to calculate the mean and the standard deviation for question 26. You can repeat those process for 27, which is the question now, and then for also question 28, just so you guys can have a reference on how to find the mean and the standard deviation. A, let's state the hypotheses, the null and the alternative hypotheses. Now, the null hypothesis states that there is no difference between a parameter and a specific value that represents the parameter. Because we're focusing on averages in this case, the parameter that we're going to use is mu. When there is no difference between a parameter or a value, rather a parameter and a value, that means the parameter is the same or the parameter is equal to that value. Therefore, mu is going to equal to the population average of $50.07. The alternative hypothesis states that there is the existence of a difference between the parameter and the specified value. The parameter is mu because we're focusing on means. And let's see if we're focusing on a specific direction. It says at the 0.05 level of significance, can it be concluded that the average phone bill has increased? This indicates that it will be a right-tailed test, which means that mu should be greater than $50.07. And this here is, well, this can be considered the claim. Now, let's find the critical value and the number of the degrees of freedom. First thing is first, let's state the direction of this test. Our direction is a one-tailed test to the right. The alpha in this test is 0.05, and our degrees of freedom is the sample size minus 1. We have a sample size of 10 data values, so our degrees of freedom are 9. And that is one of the answers to this question, which is find the degrees of freedom and then state the critical value. Therefore, we can go into the t distribution. Degrees of freedom 9. Alpha is 0.05. Direction is one-tailed. And find the t critical value for this question. Degrees of freedom 9. Alpha is 0.05. Therefore, our critical value is positive 1.833. Part C says to compute the test value, and then it says to find the p-value. Let's compute the test value first by using the t-test value for the one sample t-test. T is going to equal to the sample mean, which is $56.11, minus the population mean, which was stated to be $50.07, divided by the sample standard deviation of $6.97, divided by the square root of the sample size, which is the square root of 10. All answers should be to at least 3 decimal places. The top will be 2, of course, because we only have 2 decimal places up there. 56.11 minus 50.07. That's going to equal to 6.04. Let's do the bottom. 6.97 divided by the square root of 10. 3 numbers after the decimal should suffice. 2.204. Let's divide that and take 3 numbers after the decimal. That's approximately 2.740. That is our test value in this case. Now there's a second part to see. It says, what is the p-value interval? When it comes to the p-value interval, you need to know these 3 things first. The degrees of freedom, which is 9. The direction, which is a one-tail test. I'll put to right in parentheses. And the test value, which we just found, which is 2.740. Now let's find the p-value interval by opening up our t distribution. So it's going to be a little bit different in this case. We are going to, well, actually, let me do this like this. Let's highlight the degrees of freedom of 9. Now, what we want to do is we want to find 2 values where 2.470 will fall in between. Change our color. And the 2 values that 2.470 will fall in between is 2.262 and 2.821. Because this is a one-tail test, we're going to use the one-tail alphas to help us find the p-value interval. Because the test value of 2.740 is in between those 2 values, our p-value will be in between these 2 numbers up here. But you must say it in order from smallest to largest. The p-value will be in between 0.01 and 0.025. And that is your p-value interval. Step number 4 is to make the decision. We're going to do it 2 ways. Way 1 will be for the traditional method. And this is using the critical value. Way number 2 will be the p-value method. For way number 1, you must draw the bell-shaped curve and then put 0 in the middle. Place the critical value on the bell-shaped curve. The critical value in this question, CV, was positive 1.833. You can go back to step number 2. Here it is, 1.833. And because this is a right tail test, shade into the right side of the curve. Now, if your test value lands in the shaded area, you're going to reject the null hypothesis. And if the test value does not land within the shaded area, do not reject the null hypothesis. Our test value is 2.470, which we calculated using the t-test formula. 2.470 will fall somewhere over here. Which means we are going to reject the null hypothesis. For the p-value method, it says if the p-value is less than or equal to alpha, reject the null hypothesis. If the p-value is greater than alpha, do not reject the null hypothesis. Alpha is 0.05. The p-value interval is from 0.01 to 0.025. If you notice, both of these numbers are smaller than 0.05. I'm gonna write it here in blue. Both interval values are smaller than 0.05. Because both values are smaller than 0.05, that means that the p-value is also smaller than 0.05. And remember, the p-value is alpha. Therefore, the p-value is smaller than alpha. Reject the null hypothesis. So once again, we are going to reject the null hypothesis because the p-value is smaller than alpha. Once again, because both interval values of the p-value is smaller than alpha, which is 0.05, that means that the p-value is also smaller than 0.05. Since 0.05 is alpha, that means the p-value is smaller than alpha. Reject the null hypothesis. And to summarize the results, because we rejected the null hypothesis, we're going to state the following, that there is enough evidence to conclude that the average phone bill has increased from $50.07. From the average, I should say, of $50.07. And that is it to this video. So the reason why I made my decision in two ways is because we are doing two methods. We found the critical value, so that means traditional method. We found the p-value, which also indicates the p-value method. Either way that you choose, you notice you make the same decision, which leads to the same conclusion. All right, guys, I'll catch you in the next one. Take care.